All right, we're going to deal with another one of these parametric equations that we dealt with before, where x and y are both a function of some other variable we're calling t. So I'm going to input t, different t values, into a little rule. I have 9 minus 2t for x, and I've got 1 plus t for y. And I'm just going to input these different t values into these rules, output x and y coordinates, and then I'll plot those x, y coordinates on the graph, and we'll take a look at them. Now, this is very similar to those bug problems we did earlier, with the exception that in all those problems, t was time, and so it didn't really make any sense to have negative values for t. So here t is just another variable, another input variable, and it can have negative values. It's not necessarily time. All right, so let's take a look. Let's see, if I plug in -4, I get, let's see, 8 plus 9 is 17. Uh-oh, it's probably off my paper a little bit. -3 would be, let's see, wait a minute. Okay, I just want to make sure I was clear here. I'm plugging in -4 for t. 2 times -4 is -8, and 9 minus a -8 is a positive 17. So -3 times 2 would be, let's see, -6, and 9 minus a -6 would be 15. For -2, 2 times -2 is -4. 9 minus a -4 is 13. And I'm just going to pause and finish the rest of these out to save you the bother of listening to me do that over and over again. Now we'll do some y values. Let's see, -4. 1 plus -4 would be -3. If I plug in -3, 1 plus -3 is -2. If I plug in -2, 1 plus -2 is -1. And I'll fill out the rest of the table on my own. Now I'm going to go ahead and plot all these points. Let's see, 17, -3. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 1, 2, 3. Let's see. And then 15, -2. So there's 15, -2, 13, -1. Let's see, 12, 0. Or no, 11, 0, sorry. Yeah, right here. 9, 1. See, 7, 2, right here. See, 5, 3, and 3, 4, and 1, 5. There we go. So, let's see, I got a ruler over here. So let's connect these. A nice smooth line, because the assumption would be that although we didn't try any t values that were like 1.5 or 2.8 or anything like that, but the assumption would be that if these are all a straight line, that the x and y coordinates for the points created by those t values would just be in between what we're dealing with now. All right. So again, we've got x and y, and they're functions of some input variable t, and I have a function rule for each. So I just filled out a table based on those two function rules, and then I plotted the points afterwards. Notice, by the way, that I have -2 for a coefficient and 1 for a coefficient here. And our slope is -1/2 for this overall line. Right? And there seems to be a connection between our slope, because I have a 1 and a 2, and I have a 1 and a 2 up here. There seems to be a bit of a connection between our slope of our line and the coefficients of our of t in both of our formulas. So something to think about when you try out your own problems. See if that relationship seems to hold. Is there a connection between the coefficients of t in your two function rules and the overall slope of the line that they create.